Hello and welcome to this year's Awesome Day online conference for 2022. My name is Jack Romanos and I'll be your AWS technical trainer for this session, Introduction to the Cloud. As a technical trainer for AWS, I spend most of my time working with those interested in learning about AWS services, from a technical how does this work perspective, to a hands-on how do I use this in my operational environment, to how can I architect a solution to meet my business needs. I teach a variety of courses, such as architecting on AWS and developing on AWS. I especially enjoy facilitating a discussion with a customer that gets us thinking in whole new ways of doing things. Since the cloud is an ever-changing space, it's always great to hear about new use cases and customer stories. It is a pleasure to walk you through some different foundational services, as well as some new ones in this year's Awesome Day. This year, we'll be walking through some fundamental concepts, key service areas to kickstart your learning journey and help you prepare to start building on AWS. In addition to that, we'll be discussing a few innovation areas you might be interested in knowing more about. This session serves as a great intro to the AWS cloud. So if you're new to AWS or just looking to learn more, you're in the right place. First up on our agenda, we're going to do an introduction to AWS. This is a great place to start for those who have not used AWS before, or brand new to the cloud. We'll start getting into some key service areas: compute, storage, databases, networking, and security. In the second half of our session, we'll shift our focus to some other services that enable innovation on AWS. We'll cover some different topics, such as Internet of Things, machine learning, blockchain, AWS ground station for satellite communications, and then also we're going to talk about AWS Wavelength, relatively new service underpinned by 5G technology, and how we can use that to expand on applications that are possible today. At the end of our session, we'll talk about next steps and what you can do to get hands-on, start building, continue learning, and maybe even get AWS certified. So, let's get started with an introduction to the cloud. Firstly, what is the cloud? I like to think of it as simply someone else's computer. But what does that mean? Well, you're connected to this Awesome Day session on your computer, maybe your personal laptop, maybe your work laptop, but either way, you're primary user of that computer. You use it, you keep it secure, you restart it when you have to install updates. Essentially, you're in control of it. But on the flip side, if you break it, you're responsible for that. With the cloud, someone else takes care of that for you. You don't need to manage the physical side. You just get to run your favorite applications without having to deal with underlying infrastructure. So, what is AWS Cloud? Essentially, it's a set of programmable resources. The use of IT assets as programmatic resources allows you to quickly set up, tear down infrastructure in a way that isn't possible with traditional approach. Secondly, the AWS Cloud gives you access to many higher-level services and features, which let you design and build applications in completely new ways. You can increase database throughput or compute power, and we'll see later in just a few clicks. And then last, one of the biggest benefits of cloud computing is the ability to pay as you go, letting you test and leverage the system without being fully committed. You can stop using these services at any time and change tactics to fit your needs. This is all fine and good, but what are the advantages of using the cloud as compared to, for example, your own on-premise environment? Firstly, we have trading capital expense for variable expense. Instead of investing heavily in data centers and servers before you know how you're going to be using them, having variable expense means that you're only paying for those infrastructure resources when you consume them. And by taking a cloud computing approach that offers the benefit of variable expense, companies can implement innovative solutions while saving on costs. What this means is you can deploy a workload and start getting immediate return on investment without having already committed a large financial outlay and the associated risks that it entails. The second advantage is that we are benefiting from a massive economies of scale. By using AWS Cloud, you can achieve a lower variable cost than you can get on your own. Because usage from hundreds of thousands of customers is aggregated in the cloud, AWS can achieve higher economies of scale, and that economies of scale translates to lower pay-as-you-go price, because AWS passes that cost saving along to you. Next, you can stop guessing about capacity. You no longer have to think about what your infrastructure capacity needs are going to be in maybe 3 or 6 or 12 months or even 7 years from now. When you make a capacity decision before deploying an application, you're often going to end up either sitting on an expensive, idling resource that's not being used, or maybe dealing with limited capacity if you decide to set aside less resources up front. By utilizing the AWS cloud, you can provision only the resources that you need for a given capacity and add or remove resources as your requirements change. Which leads us nicely to increasing speed and agility. In a cloud computing environment, new IT resources are really just a click away. It no longer takes weeks or months for developers to access resources. The resources can be available in minutes. This allows you to respond to unexpected capacity changes. For example, marketing campaign was more successful than you expected. Or plan accordingly to expected changes, for example, your overnight load versus peak load during the day. This also enables another benefit. Organizations and teams can spin up a proof of concept, and if it's not working out exactly as intended, they can fail fast, so to speak, and stop using that resource right away. As a result, organizations can iterate their development process quicker and at a lower cost, and ultimately go to market sooner. We have this term undifferentiated heavy lifting, which refers to the actions and tasks that you currently perform that you don't add direct value to your business. For example, you might work for a business that has a data center. You have to purchase the equipment, employ administrators to manage that equipment and ensure it runs optimally over its lifespan. Now think about this. Your competitors likely have a similar administrative overhead. They have to run data centers with equipment that needs maintenance. So how do you set yourself apart? Let AWS manage the physical infrastructure. Stop spending money on running and maintaining data centers and focus on what actually matters to your business, to your customers, to your staff, and to your product. The last benefit that we have here is the ability to go global in minutes. You can easily deploy your application in multiple regions all around the world. As we'll see, with our infrastructure, you can achieve global scale with just a few clicks. This means you can provide lower latency, a better experience for your end customers or your end users at minimal cost. So, that brings us to how does the cloud fit into your landscape? If you think about your own environment, whether it's on-premise or located in a data center, you have servers, storage, networking, and databases. Ultimately, you have applications and workloads running on your physical infrastructure. The cloud doesn't operate all that differently. You're still going to have all those resources and the ability to access them, but you're going to do it in a much more flexible manner over the internet. We'll talk about some of the ways you can do that as we get into networking later. If you think about what you have on premises, AWS has services that you can map to meet the need. Thinking about security, you might already be familiar with firewalls, access control lists, maybe even have network or security administrators within your team or your company. AWS has services that enable you to deploy similar security constructs. We have security groups and network access control lists, which we'll talk about in the networking module coming up. We've also got a service called Identity and Access Management, or AWS IAM, which helps you to provide authentication and authorization to users of different resources that we're going to talk about. So you have the ability to manage that through one service. From a networking perspective, you might be familiar with physical devices, such as routers, switches, or basic networking concepts such as IP addressing or traffic distribution and flow. We have services such as the Elastic Load Balancer, which gives you the ability to distribute traffic amongst multiple different targets or instances I will talk about coming up. And then we've got Virtual Private Cloud, or VPC, which is your private network in the cloud, allowing you to control how resources are connected to each other. When it comes to servers, you might be familiar with managing, deploying, patching, or operating servers on premises or maybe in co-location. A key AWS service to meet this need is Elastic Compute Cloud, or EC2. We'll learn more about this in the next module, but essentially, it allows you to deploy a virtual server that you can run your workloads and applications on. AWS offers a number of different storage options, depending on your requirements. Whether that's network-attached storage or persistent disk, maybe scratch space or caches, file systems to be shared between different hosts, and even simple object storage for a wide variety of applications. AWS also has more than 15 purpose-built databases. Amazon Elastic Block Store, or EBS, offers easy-to-use, high-performing block storage at any scale. Amazon Elastic File System, or EFS, provides a scalable, cloud-native NFS file system. Amazon Simple Storage Service, or S3, provides object storage, built to store and retrieve any amount of data from anywhere on the web, which we'll talk about in the next module. So hopefully, this helps you to apply your current knowledge to different AWS services that we'll talk about. In the coming modules, we'll go a bit deeper into some of the different AWS services. Let's have a look at how some of these services tie together with a simple example. Let's say you have a web application, and it sits on a server that's accessed via the internet. The web application also needs to access some external data sources. As you can see from this architecture diagram, we have different services connected together to create the environment. In the middle, we have EC2, which being a virtual server, hosts the actual web application. The application is stored onto an EBS volume, which provides block storage to the EC2 instance. The EC2 instance is deployed in a VPC, which provides networking access. As far as the data sources go, the EC2 instance can access data in S3, which is object storage, or DynamoDB, which is non-relational database. External users can access this web application via Route 53, which provides DNS resolution. We'll speak more about these services in upcoming modules. Keep in mind, this is a simple example, but you can see how by connecting different services together, you came up with a huge variety of different solutions, depending on what your requirements are. One question you might have is, well, how does this all work? How can we build a solution in AWS that connects to my on-premises environment? As I spoke about earlier, AWS Cloud is a set of programmable resources. There are ways to connect into AWS that allow direct connection between your environment and the AWS environment, enabling secure communications that bypass the internet. AWS achieves this by deploying robust physical resources around the globe. These resources are housed in data centers that are physically connected by AWS-owned network hardware. You can then access the services you need via the service's Application Programming Interface, or API, which allows different methods of interaction. More on this a bit later. Something important to consider is we have different deployment models and ideas for different cloud maturity levels. What if you work for a corporate enterprise that was set up prior to the internet? It's likely going to have a large physical infrastructure deployment that you've used and had for years. This is your on-premises environment. You're not going to want to just turn it off on Friday night, migrate everything to the cloud, and on Monday start operating in the cloud. At the other end of the scale, what if you work for a startup, a brand new company with this revolutionary idea? Chances are you're not going to have the financial capital, time, or even the desire to invest in an on-premises environment. You might be thinking of a cloud-native design. AWS cloud deployment models cover all variations across the spectrum. On-premises environments can be slowly migrated, such that you operate in a hybrid model where you have workloads and data in both your on-prem environment and your AWS environment. Whilst new, all greenfields applications can be designated with cloud deployment in mind, making use of higher level services. Two terms come to mind here. Cloud native, which refers to applications that have been designed and deployed only in the cloud. Think newer applications in your business. And in all-in cloud, where you have migrated all your workloads from your on-premises environment and are now ready to shut it down. Ultimately, it doesn't matter where you are in your journey. Once you start moving data into AWS Cloud, you can start making use of the services and advantages that AWS Cloud provides. Speaking of moving your data into the cloud, where does the cloud actually sit? Thankfully, the cloud is not some mysterious concept. Rather, it is a concrete service that has physical infrastructure deployed globally. So, if we're going to talk about where the cloud actually is, we need to learn about the AWS global infrastructure. AWS global infrastructure is primarily made up of regions, which can be thought of as geographical locations. Need to deploy a workload in Australia? No worries, deploy into the Sydney region. How about running a workload in Europe? Great, you have plenty of regions to choose from. London is just one example. There are multiple regions deployed globally, and updated lists can be found on the AWS infrastructure page, infrastructure.aws. Next, we have availability zones. Availability zones, or AZs, are a subsection of a region. An AZ is a fault-isolated domain, which allows you to create high availability within your application. Availability zones have their own power supply, network connections, and are designed to be on different floodplains and accessed via different infrastructure. This means that a single AZ failure should not impact the other AZs. This gives fault tolerance to a region as a whole. A region is typically designed with 2 or more AZs to ensure high availability and fault tolerance. Each availability zone is made up of 1 or more data centers. The data center is a highly secure facility, housing all the physical infrastructure that makes up the cloud, such as compute servers, physical disk for storage and networking equipment, amongst other devices. For the majority of your workloads, you'll interact only with the region or the availability zone. AWS infrastructure regions meet the highest levels of security, compliance, and data protection. There's currently 26 regions worldwide. Another important infrastructure element is the edge infrastructure. Displayed on the screen are the edge locations distributed globally. We use these to bring content closer to the customers to improve performance. They can also be used to increase security and reduce cost. This can be achieved by redirecting traffic to edge locations and caching content. A key service that uses edge locations is Amazon CloudFront, a content delivery network, or CDN. We have additional services that operate at the edge, including AWS Outposts, Local Zones, and AWS Wavelength. Let's take a close look at these. Starting with AWS Outposts. Outposts is a fully managed service that extends AWS infrastructure, AWS services, APIs, and tools virtually to any data center, co-location space, or on-premise facility, providing a consistent hybrid experience. Local zones is a new type of AWS infrastructure deployment that places AWS compute, storage, and other select services closer to large cities, industries, or IT centers where there is currently no AWS region. And finally, we're actually going to talk about this one a little bit later. It's AWS Wavelength, a new service that works with 5G technology. So how do we actually interact with these services? I previously mentioned one of these ways, the AWS Management Console, which is the easiest way to get started if you haven't worked with AWS before. It's an easy-to-use graphical interface. All you need is an AWS account, which is free to create, by the way. And log in, and there you are. You can access the various services that we're going to talk about today. If you're in an operations or systems administration role, you may want to use the AWS Command Line Interface, or CLI. CLI is a unified tool for managing, controlling, and automating many AWS services through discrete commands. The CLI provides a suite of utilities that can be launched from a command program in Linux, Mac, or Windows. And finally, our third option here is via the software development kits, or SDKs, which let you access AWS services through your code or applications using a number of familiar programming languages, like Python, for example. One thing that each of these methods has in common is that no matter which you choose to access AWS services, you're still interacting with AWS APIs. I hope you've enjoyed this session and found it interesting. AWS is a data-driven company, and I'd like to take this opportunity to ask you to complete a survey telling us what you thought of the session. This can help us shape and improve events and learning in the future. You can also reach out to us on the various social sites listed on the slide. Thank you for attending Module 1, but don't go anywhere. Next up, we have Module 2. Hello and welcome to Awesome Day 2022. My name is Jack Romanos and I'll be your technical trainer for this session. Introduction to AWS services, compute, storage, and databases. I'm looking forward to walking you through to the foundations of compute, storage, and database services which make up the core of any migration. They're also great services if you're looking to deploy new workloads in the cloud. So let's continue with learning more about AWS. In this first section, we're going to talk about compute. And really, to talk about compute, the first thing we need to address is Amazon Elastic Compute Cloud, or EC2. EC2 is a service we can use to deploy virtual servers. This allows you to deploy or migrate workloads directly from your on-premises infrastructure into the cloud. EC2 supports Linux and Windows, and Mac OS in select regions. It is extremely flexible. It gives you complete control over your servers. However, in order for us to understand what virtual servers like EC2 is, it's helpful for us to get a basic idea of what a server is. When you think about your on-premises infrastructure, you have purchased physical equipment, or servers. At their most basic, servers are made up of CPU for processing, memory for temporary data storage, disk for long-term storage, and networking to allow remote access. What you're seeing here is a physical host, the physical device that underpins a compute environment. When you deploy a physical server in your environment, you have access to all the resources, which is great. However, often you only use 10, 20, maybe even 30% of those resources, which means a large portion of it is going to waste, sitting idle. Resources you've paid for but not actually utilizing. EC2 is a virtual server, which means when you deploy an instance of EC2, you can deploy only the size that you need and change it when you need it. As you can see here, you can deploy an EC2 instance which consumes only the resources you need. You can choose the amount of CPU and memory, and then create a separate disk volume using the Elastic Block Storage, or EBS. We'll talk more on this later. A key feature of EC2 is something known as the Amazon Machine Image, or AMI. This allows us to select the operating system of choice and even have custom applications pre-installed to speed up deployment time. Once the EC2 instance is deployed, you can then run your applications or workloads on them, in a similar way to your existing environment. However, using EC2, we have the ability to add, remove, pause, change, resume, scale, or manipulate your instances as you will. There are different sizes and types of EC2 to help you run your workload as efficiently as possible. So to summarize, EC2 provides you the flexibility to run your workloads when you want to and how you want to. Think of EC2 as disposable, allows you to take advantage of the pay-as-you-go pricing, significantly reducing the overall cost. Now that we know what EC2 is, what are some of the distinct benefits? Let's start with elasticity, the ability to scale your application as demand changes. As an example, let's say you're running a web server. Under normal load, you expect there to be 100 users connected to your application around 12 p.m. As the day goes on, that number really starts to dwindle off. And now you're down to a baseline of, let's say, around 10 users in a given hour or given minute. But what happens if we go above the 100% we're expecting? We have the ability to increase the number of instances that serve the web traffic. We can go up to 200 or 300 or 3,000 concurrent users if need be, by increasing the number of resources under the hood. With EC2, there's various different features built in that give us the ability to scale up or down, in or out, so we can take advantage of that pay-as-you-go pricing that we talked about. The second one here is control. We have the ability to stop and start instances or pause and resume instances for certain supported instances as we need them. Again, that has a price benefit for us, the ability to save costs. When we don't need our instances to be running, we can scale down. But then it also gives us the ability to size our fleet appropriately to the amount of traffic. EC2 gives you flexibility to choose what you want when you need it. There are a number of different EC2 instance types and families we'll talk about in a moment, but you can pick the right type of instance for the right type of job. EC2 is integrated with other services, which enables you to create secure, scalable, and highly customizable environments. There are a number of other benefits to EC2, including reliability, security, which we'll talk a bit more about later. It's cost-effective because you can pick the right type of instance for the job, whether it's a small or large instance with different resources matched to the specific workload you have for EC2. There are a large number of EC2 instance types, which is great as it allows us to deploy the EC2 instance that will be most efficient and effective for your workload. The instance types are grouped into instance families, which can make it easier to understand what each type is best used for, allowing you to make an informed decision. Want to reduce the overall cost of your workload? Choose a general purpose instance. Need more compute grunt to help process application requests or batch processes quickly? Choose a compute optimized instance. Need more memory to help speed up your database? Choose a memory optimized instance. What if you're interested in machine learning or 3D modeling? Choose an accelerated computing instance. Each instance type also comes in different sizes, allowing you to be as cost efficient as possible while still getting your work done within your committed SLA. We previously learned that the flexibility was a great benefit of EC2, and pricing flexibility is no different. With multiple pricing options to fit your workload and environment, we give you the options to make the decision and configuration that is right for you. On-demand instances can be considered the list price. With on-demand, you have the greatest flexibility and control over when and how you configure and deploy your instances. This is great for immediate scalability, workload changes, temporary workloads, or workloads that cannot be interrupted, but only run for a short time. Reserved instances, on the other hand, give you a significant price reduction for workloads that run permanently. For example, you choose a 1 or 3 year commitment, and the more you pay for the commitment up front, the greater the discount. This is great for steady state workloads, like your public-facing website, for example. Savings plans are a similar concept. You can commit to a certain amount of capacity that you're going to utilize over time. Lastly, and probably the most interesting here, is spot instances, which give you up to a 90% off the on-demand price, with one caveat. Spot instances are not guaranteed to run permanently. This means that you need to be strategic about how you deploy them. However, they're great for the ultimate cost reduction. As an example, most stateless applications can use spot instances and benefit from the lower cost. We're now looking at the AWS Management Console. Using the console, I'm going to demonstrate how to deploy a simple public transport application built by launching an instance using the EC2 service. We'll first navigate to the EC2 service dashboard, and then we'll select the Launch Instance button. From here, we'll step through a wizard to go about configuring the launch details of my new instance. I'll give this a name, which will just be Jack's Transport App, and then I'll select the Amazon machine image, which will include my choice of operating system, the latest version of Amazon Linux 2. I'll then change my architecture to use ARM. From here, I'll select my instance type. This is a simple web application. I'll choose an instance type that's most appropriate for a typical web server with 2 virtual CPUs and 2 GB of memory. I'll then opt out of selecting a key pair, as I don't need to connect to this instance remotely. I can configure my network settings, but for this demonstration, it's fine to leave most on default. I'll however make some network security changes to allow public HTTP web traffic to the instance from anywhere on the internet, so that later we can access my transport application. I'll leave my storage settings on default, where it has an 8 GB root volume attached to the instance. Lastly, I'll add a script which will install my application and its dependencies upon launching my instance. I'm now all set to launch my EC2 instance and check out my transport application. My new instance will have a unique ID and a link to view it. This will take me to a dashboard showing my instance details. When I select my instance, you'll see here that it's now in a running state. In the Details tab, I can see information about the instance, such as its public and private IP address. In the Security tab, I can see security details, such as its inbound and outbound rules. Under Networking, I can see its virtual private cloud and subnet. Under Storage, I can see its attached EBS volumes. I also have tabs available for status checks, monitoring the instance metrics, and managing resource tags to find instance or group it among other resources. At this point, my application should have been deployed on my instance. So I'll copy its public IP address and paste it in my browser. Now we're able to view my transport application running smoothly on my instance, and I can log in and test my user account. Now that I'm logged in and I can see my routes, I now have a functional transport application that I can use when planning my trips around New South Wales thanks to the EC2 service. After I've finished with my application, I can terminate my instance as I no longer need it. I'll select my instance state and then I'll click Terminate. My instance is going to be shut down and then removed from my AWS account, so I no longer have to incur any costs. Another concept that I want to introduce here is unmanaged versus managed services. With unmanaged, you need to manage the scaling, the fault tolerance, and availability on your own with your application or architecture. Keep in mind that if you were running this application on premises, you'd be managing this anyway, including managing the physical infrastructure. But one of the key advantages to some of the services that we're going to be talking about here is that there's actually a managed, or in some cases, fully managed option where you don't have to worry about the scaling, the fault tolerance, and the availability, which are built into that service. And so the reason I introduced that is we're going to now shift gears a little bit and talk about serverless computing, which is something you may have heard of. EC2 is great. It's extremely powerful, configurable, flexible, and gives you control over your application and how it runs. But that power comes with responsibility. You must manage fault tolerance, high availability, scalability, the operating system, and application patches, access, permissions. It's a full server. But maybe you don't want to worry about the administrative side of compute. You just want to run some code. Maybe you have an application where some parts get run frequently and others not so much. Maybe you have an ad hoc calculation that needs to be run, or reactionary code that responds to events in your environment. Having a full server sitting there, idling, waiting to be interacted with, it's quite a waste of resources. So how can we do this better? With serverless computing, we have the ability to build and run applications and services without managing the servers that we just talked about. So we can still get the outcome of running specific code or function without having to manage all the underlying components. A key benefit here is no service to provision or manage, which leads us to never paying for idle resources. And so this is where serverless can greatly help us. If we can run our applications in a serverless manner, we can actually save by never paying for idling resources. So now that we've talked about what serverless computing is, let's talk about the heart of serverless, AWS Lambda. Lambda is a fully managed compute service, which runs stateless code, supports multiple different programming languages, and you can run your code based on a trigger or schedule that you choose. This gives us some great benefits. Previously, we talked about EC2 instances, which require us to provision or choose the right type of instance to run our application. With Lambda, we just need to add our code to something called a Lambda function, then tell it when to run. Lambda manages the execution and completion of the code. You don't have to worry about deploying infrastructure or anything. AWS Lambda excels at executing short-running, stateless code that has a defined start and finish. For code that runs indefinitely, you want to stick with something like EC2. But a little cloud design allows you to take advantage of what Lambda has to offer. Lambda also helps us add automation into our environment. Whether it's an automatic logging, response and remediation, incident management, analysis, the list is endless. Let's look at an example using Lambda. We're going to have a basic scenario where a user could upload a picture to a storage location, in this case an S3 bucket. We'll learn more about that in the storage section coming up. We want to do some image recognition when the image lands in the bucket, so we invoke a Lambda function to use an image recognition service when this occurs. So in this example, a user uploads a picture to S3. S3 triggers Lambda, and Lambda uses another service to perform image recognition, then it stores the results in a text file back in the S3 bucket. We'll call this an event-driven architecture, where there are no active servers running. Let's look at how this is built. I'm going to walk you through an environment that is pre-built to show you how it all ties together. We're now looking at the Lambda dashboard in the AWS Management Console. From here, we can create our Lambda function. We're going to author one from scratch and give this a name of Awesome Image Recognition. We'll then select our favorite runtime, I'm happy with Python 3.9 and the ARM architecture. I'll then change my default execution role. This will give my Lambda function permission to access the images in my S3 bucket and to perform image recognition on them. So I'll choose an existing set of permissions that I've already pre-configured. I'm now ready to create my Lambda function. Now that my function is created, you'll see that I can edit my function code. It has some example code for me to begin with. However, let's replace this by pasting in my own Python code. This code allows us to receive an image from an S3 trigger, perform image recognition, then store the results of it back in the original bucket as a text file. Once we've added our code, we can now save and deploy our function. I'll now navigate over to my S3 bucket. I'm going to edit its properties and add a trigger to invoke my Lambda function when I upload an image. So I'll scroll over to Event Notifications, click Create Notification, and give it a name. I'll specify a .jpeg only suffix so it only runs for JPEG files. I'll also make this only trigger on new upload events. And finally, I'll select my Lambda function, which we just created as the destination of this event. Now we'll click Save and test it out. I'm back at my bucket and I want to upload a photo I took, which is a delicious pan pizza I cooked the other day. It's called lunch.jpg. I'll now drag and drop lunch.jpg into my bucket and upload it. Now that it's there, you'll see it listed inside my bucket. In the meantime, this will trigger my event notification to invoke my Lambda function and perform image recognition. When I click refresh, you'll see that the Lambda function has dropped our results as a text file into the bucket too. Let's download it and see inside. And finally, I can see that it has confirmed with 99% confidence that my pizza is in fact a delicious pizza. There are many other serverless services within AWS that we can integrate together. We saw the event notification from S3 as an example, but let's see other applications and use cases for serverless. So in the example that we just saw with Lambda, we did something very simple. But what if we want to create an entire backend? We can also do that in a serverless fashion as well. We have many different Lambda functions and other services within AWS that will integrate with Lambda so that we can create an entirely serverless backend. Maybe you're performing data processing or creating reports. Maybe even having chatbots or other IT automation tasks. All serverless in the backend, and we don't have any running or worst case idling resources. This is one of the key advantages of going the serverless route. In some cases, you might not want to run a full EC2 instance 24/7 waiting for actions to occur. But what if you have a job or something that is going to take a short period of time, but needs to run longer than it could within Lambda? Containers can really help us here. Amazon's Elastic Container Service, or ECS, is perfect for orchestrating the execution of your containers. This can be done on EC2 or even have ECS manage the infrastructure deployment for you. It maintains and scales the fleet of nodes that run your containers and removes the complexity of standing up the infrastructure. Containers give us a balance between the long-running compute that EC2 gives us, whilst also being extremely quick to scale and run, which is where Lambda excels. Let's have a quick look at how Elastic Container Service helps us manage container orchestration. So, ECS actually gives us the ability to schedule and orchestrate the deployment of our containers, as they're called across multiple or even a fleet of EC2 instances. Typically, this is a complex activity because it requires determining where you might place those containers using a placement engine. And so, the ECS service gives us the ability to manage containers at a scale on EC2, We've spoken a lot about compute, EC2, Lambda, and ECS. Let's move on to storage on AWS. We have a number of different storage options, depending on your application's needs. S3, or Simple Storage Service, is a scalable, highly durable object storage in the cloud. We've also got S3 Glacier for low-cost, highly durable archive storage in the cloud. We've previously mentioned EFS, a scalable network file storage service for multiple EC2 instances. We talked about hybrid cloud deployment in previous module. With Storage Gateway, we've got a hybrid cloud storage service that gives your on-premises environment access to virtually unlimited cloud storage. And lastly, we have EBS, which we saw when deploying an EC2 instance. EBS is network-attached volumes that provide durable block storage for EC2 instances. Let's start with S3. S3 is object-level storage, which means S3 manages the storage layer for you. S3 is designed for what we call 11 nines of durability. Durability is a measure of how likely you are to lose a file or object. For example, if you store 10 million objects with Amazon S3, you can on average expect to incur a loss of a single object once every 10,000 years. That's extremely durable. But there is no limit to how much data you can store in S3. So you can store as many objects as you like. However, each object cannot be larger than 5 terabytes in size. We previously saw event triggers in the Lambda demo. This is a great feature of S3 that enables fantastic automation and event-driven architectures. S3 objects are stored within buckets, which are basically like containers that you create. You can also enable replications of objects between different buckets to create additional copies that data within the same region, or maybe even a different region if you need to. And then similar to our pricing discussion before with EC2, you can also utilize different pricing models for your storage data, depending on different access patterns that you might have for your application. These are called S3 storage classes and range from immediate accessibility for hot data all the way to archival options with long access times for cold or frozen data. Some example use cases for S3: content storage and distribution, backup and archival storage for big data and data analytics, disaster recovery, and static website hosting. There are a few main things to understand about the S3 service. It's built to store and retrieve data. It offers fast, curable, highly available access to your objects. As I mentioned earlier, you can store an unlimited number of objects in a bucket. A key benefit to S3 is that you can access objects from anywhere on the web, whether it is serving externally to a user or internally within your environment. So let's actually look at an example here of what a round trip looks like. So you might have a client, let's say either an end user through a web browser or a web interface, or potentially an application that is looking to get or retrieve data from S3. The client will need to send through a HTTPS request to get an object from the bucket. The S3 service then sends the object back to the client. It's that easy to retrieve and store data in S3. In the introduction to the cloud, we spoke about AWS Global Infrastructure. One of the infrastructure elements is a region, which is a geographical location. It's important to think about which region to place your resources and store data in. Generally, it comes down to 3 or 4 priorities. The first priority is data residency or compliance. If you have a regulatory or legal requirement that dictates where your data is kept, maybe it has to stay within the same country it originated from, then you must choose the appropriate region. However, if this is not the case, then you have some flexibility to choose. Secondly, we want to locate the service as close to the customers who are going to use it. This will help improve performance and give them a better experience. Third, it comes down to service and feature availability. Not all services are available globally, so sometimes you might choose a region that actually contains the service you want to use. And then last, but by no means least, is cost. Different regions have different prices. sometimes choosing a different region can help you reduce costs of your workload. So let's move on to Amazon S3 Glacier. S3 Glacier is designed for long-time, infrequently accessed archival storage. The key difference between S3 and S3 Glacier is access time and cost. With S3, objects are accessed immediately. Want to load up an image for your website? It's right there. With S3 Glacier, however, there is an access delay. This can be between minutes to hours, depending on how you configure your environment. However, with that access delay comes a drastic reduction in storage cost, sometimes as low as 90% cheaper than S3 standard storage. With S3 Glacier, the focus is on long-time archival storage. Some example use cases are healthcare or financial information that you need to keep permanently, but only access rarely. Maybe you have a video asset where you keep the raw or mezzanine quality videos in low-cost storage, which allows you to reuse later if need be. When thinking about using S3 Glacier, just ask yourself, how much data am I storing? How long do I need to store it? For how often do I need to access it? And what cost is acceptable for storage? The last service we'll talk about in this section is Elastic Block Store, or EBS. We saw how this service is used with EC2 earlier. It provides persistent block storage for our EC2 instances. EBS volumes come in a variety of different types with different underlying physical components. This allows you to apply an appropriate volume to the type of workload. For example, if you are running a database that is reliant on low latency random access, a provisioned IOPS SSD may be perfect. However, if you're more interested in streaming large logs files, then throughput optimized hard disk drive may be better suited. The volume types also let you reduce your cost for storage. EBS volumes also support snapshots, which are backups of your volumes. These snapshots are stored in S3 behind the scenes, so you get great availability and durability of your backups. Lastly, EBS supports at-rest encryption to keep your data secure. Next up, let's talk about databases. AWS has the broadest selection of purpose-built databases for all your application needs and allows you to scale your largest and most complex workloads so you can grow to reach more customers. Listed here are some examples of databases that could fill your needs. Earlier, I introduced the concept of unmanaged versus managed services. Well, here I want to talk about do-it-yourself databases versus AWS managed databases. You can definitely run your database choice on EC2. There are a few valid use cases for doing this. Maybe you need to access the underlying operating system to install helper services. Or maybe you need to use a database engine for legacy compatibility that AWS doesn't support. However, if you go down this path, you must manage the high availability and fault tolerance, the database backups, primary, secondary replication, operating system, and database engine patches. The administration tasks are quite extensive. Running a database on EC2 is an example of using an unmanaged service. You could instead, though, choose to deploy your database on one of the AWS managed database services. Some examples are Amazon Relational Database Service, or RDS, for SQL-based databases. There's also Amazon DynamoDB for NoSQL databases, Amazon Elasticache for in-memory caching, or Amazon Redshift for data warehousing. When choosing a database, previously it was always we have an SQL-compatible database, this is what we use, so this is what we'll continue to use, even if the use case didn't really fit. Now with the cloud, you have a plethora of database options to choose from. Our first choice must be to SQL or NoSQL. SQL databases are great when needing to join tables, needing to perform complex analysis, or have a flexible yet complex querying. Maybe you know what your data looks like, but you don't know how you want to query it. NoSQL databases, on the other hand, can be extremely fast and provide low latency responses. They support ad hoc data structures and can scale differently to a traditional SQL-based database. So, how do you choose? For a relational style database that has transactional requirements, look no further than Amazon Relational Database Service, or RDS. If you need a relational style database but require analytical processing, then Amazon Redshift is your service. For storing your data in a non-relational way for transactional databases, Amazon DynamoDB may be a good fit for those needs. But you might also need a graph database, which is more focused on the relationship between data points rather than the data points themselves. You might use this for fraud detection or recommendation systems. Amazon Neptune has you covered there. Lastly, Amazon Elasticache provides a caching solution and is available with two popular caching engines, Redis and Memcached. This is only a sample of databases on AWS, but regardless of your application's needs, there's a purpose-built option that you can migrate to or stand up in the cloud. So first up here, we have Amazon RDS. RDS makes it easy to set up, operate, and scale a relational database in the cloud. It provides cost-efficient and resizable capacity while managing time-consuming database administrating tasks. And that frees you up to focus on your applications and your business. RDS supports 6 familiar database engines that you can choose from, including Amazon Aurora, which we'll talk about, Oracle, Microsoft SQL Server, Postgres, MySQL, and MariaDB. Amazon RDS also provides a number of features that make it easier to manage common database tasks. Once you've created your RDS database, you can configure automatic backups and maintenance windows while working around your application traffic. By default, Amazon RDS enables automated backups of your database instance with a 7-day retention period. RDS also gives you the ability to run your database instance in a multi-AZ deployment, which increases fault tolerance by maintaining a synchronous replica for automatic failover. Lastly, you can scale the compute resources and storage capacity needed for your database over time as your data or your demand for your database grows. We've also got Amazon Aurora, which is a MySQL and Postgres compatible relational database built for the cloud. It combines the performance and availability of high-end commercial databases with the simplicity and cost-effectiveness of open source databases. Aurora is built for high availability and durability. It's also built for high performance and scalability, whilst providing multi-regional capabilities. There are some neat features of Amazon Aurora that sets it apart from other relational databases. Aurora has a distributed, fault-tolerant, and self-healing storage system. The data blocks are continuously scanned for issues and repaired automatically. You can utilize up to 15 read replicas on Amazon Aurora across multiple availability zones, which share the same underlying storage volume as the primary database instance. This enables really great read scaling and high availability for your applications. Another great feature is Amazon Aurora Serverless, which provides on-demand access to your data with automatic startup, shutdown, and scaling. This is another great option to save costs on those unpredictable or spiky workloads. The last thing to mention is that Aurora is up to 5 times faster than standard MySQL databases and at a tenth of the cost. Next up, we have Amazon DynamoDB, which is a fast and flexible, non-relational database service for applications that need consistent, single-digit millisecond latency at any scale. The fully managed nature of DynamoDB makes it really flexible for many different use cases, but also takes away a lot of the management tasks. DynamoDB handles all the partitioning of data in your table, so you don't have to worry about managing those different partitions yourself. You also get fine-grained access control with identity and access management. And since there's no underlying instance to manage, you can configure the read and write capacity for your DynamoDB tables, ensuring that your application has the right throughput. Where you might have spiky workloads, DynamoDB features on-demand and adaptive capacity options. In most cases, DynamoDB offers single-digit millisecond response times, but sometimes your application needs even faster response times. In these cases, we have something called DynamoDB Accelerator, or DAX for short, which is an in-memory API-compatible cache that reduces response times down to microseconds. Lastly, DynamoDB provides the ability to create a multi-region, multi-active configuration with something called DynamoDB Global Tables. And that frees you from having to roll your own replication solution. Talking quickly about a DynamoDB use case. Companies in the gaming industry use DynamoDB and all capabilities of game platforms, including game state, player data, session history, and leaderboards. As there is little operational overhead, game developers can focus on developing their games instead of actually managing databases. I hope you've enjoyed this session and found it interesting. AWS is a data-driven company, and I'd like to take this opportunity to ask you to complete a survey telling us what you thought of this session. This can help us shape and improve events and learning in the future. You can also reach out to us on the various social sites listed on the slide. Why not test your knowledge? Make sure you complete the knowledge check after the session to see how you're progressing. Thanks for attending Module 2, and stick around for Module 3.
Hi everyone, and welcome to Awesome Day Online Conference. My name is Akanksha Balani. I'm the Alliance Lead for AWS at Intel for the region of APJ, and I'm also the Global HPC and AI GTM Lead. With us in the industry today, time and time again, we've recognized is when there is a technology that's accessible, that's consumable, and when the barriers of its adoption are low, this gives rise to a crazy amount of demand. And through that demand rise various business models, various usage models, and ultimately, a lot of opportunity. Cloud computing is one such technology, and AWS has continued to bend the curve of what's possible. The rest of my session today will talk about how, with the power of AWS, Intel supporting the performance of AWS, you'll be able to unleash the power of cloud computing through various technologies with optimization capabilities brought to you by Intel. So let's get started. Let's talk about the world in which we live in today, filled with data. There is a survey that shows that by the year 2023, we shall have 50 billion devices and 500 million sensors smartly connected over the internet. 46% of these devices will communicate machine to machine. The data is upon us, and it's deluged like never before. To make sure that that data does what it needs to do to help you get the insight for solving your business challenges, your organizational business challenges, or your customers' business challenges, you need to make sure that you're adopting the right technology that can help you scale and build agile solutions for helping you drive the right insight. Cloud computing will get you there. Computational power that boosts performance on cloud computing will get you there. If you look at all the various industries on the slide, each of these industries that you either belong to or you service to or you build for are being impacted by data today. Making sure that you're modernizing your infrastructure, making sure that you're leveraging cloud infrastructure, and making sure that that infrastructure is best performant and optimized for your needs becomes a very, very important and crucial strategy that you need to apply into these industries. Since we've talked about data, since we've talked about industry transformation, let me tell you a little bit about the journey Intel has had. Intel has moved away from being just a PC-centric organization to a strong data-centric organization. So much so that 93% of the world's data runs on Intel. And those numbers are showcases on its own. Whether you see that we have 81 million Xeon processors that are supporting data center cloud to edge infrastructure, or the fact that we have 20 years plus of technology leadership that's helping make compute relevant, performant, and bring down TCO for every solution that you own. It is a data-centric journey that we take on, either on the cloud or on the edge, we want to make sure that with the performance driven on Intel, with computing that's provided on the cloud by AWS, you have the most optimized solution for your needs. I'd like to also take you through the journey of what Intel has been doing with AWS since the past 16 years. Intel has been customizing its silicon year on year, iterating on its technology to be made available on AWS's cloud platforms. If you look at the circle of services and platforms that you probably are already playing around with on AWS, whether it's the EC2 compute, or it's the storage on S3, or the various migrations that you're driving on your databases, whether it's Windows or SAP HANA or SQL Server or Oracle, all of those have the capabilities of being powered by Intel instances on AWS today. We also have very strong and very strategic workloads like AI, like HPC, like IoT, and even hybrid, where Outpost, which is their latest offering on AWS for hybrid cloud, is powered by Intel again. So as you can tell, Intel is about making sure that we have the most customized and most optimized compute capability to help power any of the workloads that you see on the slide today. And if you look to the right, you could actually see the plethora of Intel products that are available for your global workload needs. You could see that we have over 250 plus instances, and I'll go into that in my next slide. This slide actually talks to you about the portfolio of the Intel Xeon instances that are available on AWS's EC2 platforms. And as you can tell, not only is the number of instances quite intense, which is about 250 plus instances that are powered by Intel today, but you could see that it is catering to various needs of your applications, whether it's general purpose, or it's compute optimized, or it's accelerated compute, storage, or memory. Depending on the need of the application and the instance type, we are there with you hand in hand to help provide the lowest TCO at the highest performance. If you look at the range of AWS instances that are powered by Intel technology, we work together to design instances by the compute or memory or storage optimized ones to ensure demanding enterprise applications can run in an optimized and scalable manner in the cloud. The goal is one architecture from edge to the cloud, so that if there is any optimization we make in the cloud, this will also benefit at scale. Let's dig a little deeper into what I just discussed. It's easy to claim industry-leading price performance now, but I'd like to back that up with data. Recently, in an article published by HPC Wire, Amazon EC2 instances powered by Intel measured at having a 1.25x higher performance and price in SpecInt over other x86 technologies. Why does this matter? Intel's architecture can do more with less. This translates into real savings for you, especially when considering the impact of software licensing. A single core of Intel Xeon scalable processors will do what takes 2 or 4 cores, depending on the workloads of another technology. Again, this is about delivering both value and performance. Now that I've explained the performance numbers, let's discuss value. Intel has over 20,000 software engineers that work out of our 1,000 ISV ecosystem partners to optimize, validate, and test applications. So each new version of VMware, Microsoft Windows, Microsoft SQL, Oracle, SAP are all optimized and validated to work on past, present, and future Intel architectures. This allows you to focus on your business and not on revalidating your architecture when transitioning onto AWS Cloud. Again, to back that up with data, the next 2 data points show the workload optimization work that has been done by Intel and AWS to deliver up to 1.7 million transactions per minute on MS SQL. For those of you who work with databases, you know the work involved with SAP HANA. AWS, powered by Intel, is SAP certified and delivering up to 480K SAP's benchmarks. Again, this is where the value of Intel in your AWS cloud instances matter. You can focus on running your business, knowing that Intel and AWS have delivered industry-leading certified performance to meet your needs. I'll now go into the actual portfolio of the Intel instances that are available on AWS EC2 today that are optimized by your use case. It's not exhaustive, and it's definitely focused on trying to get you access to the latest and the greatest instances that are available on EC2 today. So for those of you that are building on balanced workloads, which are basically catered towards general purpose, you can use the T3s, the M5s, the M5Ds, as well as the M5ZNs. These are the set of Intel Xeon instance families that help you with general purpose application optimization. When you move forward to more advanced workloads, compute-intensive workloads like HPC, like data lakes, like AI, or network appliances, the compute-optimized versions are C5, C5D, and C5N. Of course, I'm not going to get into the details of the actual hardware features that are powered on each one of those. These are available for your view on the slide. But you could see the performance, the number of vCPUs, the core count, as well as the memory that you can get access across each one of these instances. The third is high-performance databases, in-memory databases. If you are a DB person, you want to make sure that you are trying to drive the best memory and optimized journey of the memory that you require for your application. Use the R5s, the R5Bs, the X1s, the X1Es, the Z1s, or the bare metal instances. They will get you that performance because they're custom built for in-memory database application development. And then let's move on to high IOPS at low cost for storage optimized applications. The i3s, the i3ENs, the H1s, the D3s, and the D3ENs will get you that capability of making sure that you have the highest IOPS at the lowest cost, get you that storage optimized experience for the applications on AWS. And lastly, let's look at accelerated workloads like machine learning or 3D rendering, which is under accelerated compute. Whether it's AI or it's any of the other extended workloads for training or inference, Intel Xeon instances are powering the P3DNs, the G4s, the F1s, and also the latest and the greatest to be coming in shortly across the world are the Habana Gaudi instances that are specifically meant for providing you a 40% better price and performance over existing deep learning GPU-based training instances on AWS today. So if you're looking for the broadest choice of optimized instances that are tuned for your enterprise workloads, try out the various Intel instances that I went over on AWS's EC2 platforms. For all of you data-centric workload developers, application managers, when you're working on database migrations, when you're working on data analytics or big data on AWS across the various databases like SAP, SAP HANA, VMware on AWS, Oracle, or SQL Server, you could see the various hardware features that are nurturing the best price as well as performance on Intel-powered instances. In addition to just the data-centric workloads, you also saw me talk about the Habana Gaudi processors on machine learning and AI that will provide you the 40% better price as well as performance on existing GPU training instances on AWS today. Not only will Habana processors help you on your training journey, but the existing C5 instances that are powered by Xeon that have deep learning boost capabilities, vector neural network instruction sets, as well as AVX512 instruction sets built into our hardware, they will also help you basically start your journey on AI on CPU-powered instances, which will give you an immediate price as well as a performance betterment. In addition to AI and ML, we also have HPC as a very strategic workload. We have been working with HPC customers since over 50 plus years. And so the optimizations across HPC workloads and further optimizing AWS's HPC offerings like parallel cluster, EFA, under C5N or C5 or M5 is an experience you will get like never before. Also, in addition to that, if you're embarking on your hybrid cloud journey, you've got Amazon Outposts that are powered by Intel instances today. We also have various COEs that we have also launched in APJ that will help you get that experience of hybrid cloud for you to really experience the optimization capabilities on hybrid on Intel and AWS. Also IoT. For all of you IoT developers and people working in the edge or the IoT world, we also have IoT Core and various AWS's IoT services that are powered by Intel instances. Hence, if you could look through all the various strategic workloads that I mentioned, historically, as well as existing use cases are available for you to see the price as well as performance betterment on Intel-powered instances through the optimizations and the iterations we take on technology along with AWS. Let's also hear from our friends at AWS for them to talk about their experiences on Intel-powered instances across the various workloads.
Amazon and Intel have been collaborating on new technology for over a decade. Together, we've been able to pioneer new EC2 instance families which provide dramatically more bang for buck, more computational power at lower cost, which lets customers do more for less. The new C5 instance family, which we announced in November last year, is powered by a custom Intel Xeon scalable processor with a new microarchitecture, new hardware acceleration capabilities, and support for Intel's AVX 512 instruction set. The Intel Xeon scalable processor, combined with the innovations in networking and acceleration in the C5 instance family, bring about a major epoch in the world of high-performance computing, machine learning, and artificial intelligence. It's never been easier and more cost-effective to collect data at any scale, store it in a broad set of database and storage services, and then build custom machine and deep learning models. Today, businesses deploy more machine learning workloads on AWS than any other platform, including Aon, a large insurance and capital advisory company, who is running financial simulations using machine learning on AWS, which reduced the time to complete simulations from days to minutes. And the computational power of the Intel Xeon scalable processor lets customers use more data to create innovative new products and experiences powered by machine learning. Together with Intel, we've optimized deep learning engines with the latest version of the Intel Math kernel library and the Intel Xeon scalable processors available on the new C5 instance family to increase inference performance by over 100x. We've also worked closely with Intel to demonstrate how you can use familiar tools such as Apache Spark and BigDL to easily build distributed deep learning applications on AWS. High-performance computing allows engineers and scientists to solve complex, compute and data-intensive problems. HPC apps often require high network performance, fast storage, large amounts of memory, and very high compute capabilities, making them an ideal workload for our compute-optimized instances, including the new C5. Running these workloads on AWS gives customers instant access to thousands or tens of thousands of EC2 instances running Intel Xeon processors, allowing them to increase the speed of research in a cost-effective way that would not be practical in most on-premises HPC environments. For example, Novartis used 10,600 EC2 instances and approximately 87,000 compute cores to conduct 39 years of computational chemistry in just 9 hours, screening 10 million compounds against a cancer target. This magnitude of improvement is changing what is possible in industries such as healthcare, life sciences, financial services, scientific research, aerospace, automotive, manufacturing, and energy. We're super excited to see our collaboration with Intel continue and for customers to continue to innovate on AWS through the best performance available anywhere.
And And so to summarize, if there's 3 points that you want to take away, number one, you could see that Intel and AWS have a very close collaboration that has resulted in best-in-class end-user experience and customer successes. We would love for you guys to be part of that journey with us. Number two, instance types with the best TCO on Intel to accelerate your customers' applications across the variety of workloads that I went over. And number three, we have existing solutions for deployment with many successful outcomes, delivering both high performance as well as cost savings. So with these three big takeaways, we invite you to embark on the journey of collaborating with Intel and AWS across the various services that you're testing out. And let's make cloud computing as performant as possible with the power of Intel and AWS. I hope you found this session useful. Thank you so much for your attention. Once again, I'm Akanksha Balani, the AWS Alliance Lead for AWS at Intel for the region of APJ, as well as the Global AI and HPC GTM Lead. Feel free to hit me up on LinkedIn or reach out to me through your AWS's contacts, and we look forward to doing wonderful things together. Thank you again.
Hello and welcome to Awesome Day 2022. My name is Jack Romanos and I'll be your AWS technical trainer for this session. Introduction to AWS services, networking and security. So if you're new to AWS or just looking to learn more, you're in the right place. Jumping right in, let's talk about networking. At the heart of networking in AWS is Amazon Virtual Private Cloud, or VPC. VPC allows you to create your own private space within the AWS cloud. You can use VPC to logically separate or isolate your workloads. Whether you're isolating dev, test, prod environments, or separating different functions due to security concerns, VPC helps you to control the flow of your traffic. VPC, like most other AWS services, is logically defined. Therefore, you can deploy as many VPCs as you need for your particular use case. It's not uncommon for larger, more complex environments to have hundreds of VPCs. Ultimately, it gives you control over the network access to your workloads, whether it be public access for those to the internet or private access to your on-premises or corporate environment. When deploying a VPC, we must allocate a range of IP addresses. We can then further partition the VPC into something called subnets. This allows us to break our VPC into segments, which we can use for high availability or security or apply different controls. The example shown here has a public subnet, which can be accessed via the public internet. You might want to have a public-facing web application here, or maybe a bastion or jump host. We also have private subnets, which do not have direct public internet access. This means that they're protected from bad actors on the internet trying to compromise your application. VPC is what we call a regionally scoped service, meaning it sits across all availability zones within the region. Subnets are availability zone scoped, meaning they sit in an individual availability zone. However, you can have multiple subnets in different AZs in a single VPC. You can have multiple VPCs in the same region or different regions for that matter. However, you cannot have a single VPC span across multiple regions. Amazon VPC also offers connectivity over VPN and another service called Direct Connect, which allows you to connect your VPC to your data center, offices, or other customer locations in a secure manner. In addition to these hybrid connectivity options, VPCs can be connected to each other, and these VPC connections can span multiple regions. So we have the ability to peer VPCs together to expand our environment if necessary. When we want to control connectivity between these different resources in our VPC, we can configure the routing options on our VPC as needed. The use of route tables, network interfaces, and interface endpoints, for example, give us complete control over the security configuration and connectivity of the resources in our VPC. So now that we know more about subnets, let's talk about how we can take advantage of different VPC features to achieve a defense-in-depth approach. When we design our infrastructure, we can achieve defense in depth. What this means is we have multiple layers of protection across the configuration of your VPC. Firstly, we have route tables. One way to protect your workloads is to not allow public internet access or restrict to outbound requests only. Secondly, surrounding the subnets, we have network access control lists. These are stateless packet filters that wrap around the subnet and determine whether traffic can enter or leave. These are good for providing explicit block rules to known problem areas or restrict specific protocols or ports. Next, wrapping around the Elastic Network Interface, a virtual network interface that allows the EC2 instance to connect to the network is a security group. The security group is a stateful packet filter that governs what traffic can enter and exit a specific instance. By default, all traffic inbound is blocked, whilst all traffic outbound is actually allowed. Lastly, on your EC2 instance itself, you can install your own firewall and protection software. In a small environment where you have a low number of instances, maybe 1 or 2 instances, then traffic distribution is not going to be a problem. But what happens when you want to scale that out? Or have a dynamic scaling that changes depending on how much load is currently being produced? You need a more sophisticated load distribution method. Bring on the Elastic Load Balancing Service, ELB. Amazon ELB comes in multiple flavors. But key here is the application load balancer. That distributes traffic according to HTTP or HTTPS rules that you configure. Amazon Elastic Load Balancers are highly available and can be used to decouple application tiers. This means your web tier doesn't need to be aware of the changes to the app tier infrastructure. It also supports health checks. So if your instance behind the load balancer fail, or maybe your application stops responding, Elastic Load Balancer can actually determine that an instance has failed. It will then stop distributing traffic to that failed instance, resulting in a better experience for your customer. And then finally, we also get security features with the Elastic Load Balancer as well. We can utilize TLS termination on our Elastic Load Balancer to unburden our instances behind the scenes. Here we are again at the AWS Management Console. In this demonstration, we're going to showcase how we can distribute traffic across multiple instances using an Elastic Load Balancer. So firstly, we'll navigate back to the EC2 service. You'll see here that we have 2 running instances, instance A and instance B. We can access both of these instances directly using their public IP addresses in a web browser. They're both running a simple application, which shows their IP address in large writing so we can identify them after we create our load balancer. Our first step in this demonstration is to group these instances together by creating a target group. We'll give this target group a name and simply call it Instances Group. Then click Next. We'll then add both of these instances to our target group. Now that we have both instances added, we can then proceed to create our target group. Now that our target group is created, we can proceed to creating our load balancer to distribute traffic across the instances in our group. So we'll select load balancers, then create load balancer. We're going to choose an application load balancer to distribute our web traffic. We'll give this load balancer a name and just simply call it Jack's Elastic Load Balancer. We'll leave it as an internet-facing and map the load balancer to distribute traffic across instances in all 3 availability zones in the region. We want to make this load balancer publicly accessible. So what I'll do is change the security group to one that allows inbound web traffic on port 80. Then I'll choose my target group so that any web traffic this load balancer receives on port 80 will be routed to the instances in the group. From here, I can then proceed to create my load balancer. It will take a moment for it to be provisioned, but once ready, I can access it using the DNS name of my new load balancer. So while refreshing my browser using the same DNS name, my load balancer is performing a round robin to distribute traffic to each of those instances registered in my target group. The Elastic Load Balancer is regionally scoped. It gives us the ability to distribute incoming traffic to multiple instances or applications in that region. But what if we want to distribute traffic across different regions? Route 53 gives us the capability to do that on a global scale. Route 53 is highly available and scalable cloud DNS service. You can use it to register domain names, or configure different routing options which allow us to determine where traffic will go. It provides tools for flexible, high-performance, highly available architectures on AWS, and we have multiple routing options. Let's see how this works. In this example, we might have a client or an end user that is trying to connect to our application that is sitting within our VPC. The end user would navigate to our URL. Route 53 would be used to resolve that into an IP address, which then leads us through our internet gateway to our Elastic Load Balancer, which distributes the incoming traffic to multiple EC2 instances, which could then respond back to the user. And we're doing all this within our VPC in the AWS cloud. We'll change direction now and talk about security. At AWS, cloud security is the highest priority. As an AWS customer, you'll benefit from a data center and network architecture that is built to meet the requirements of most security-sensitive organizations. The AWS infrastructure has been architected to be one of the most flexible and secure cloud computing environments available today. A key way to look at security at AWS, especially as a customer, is using this shared responsibility model. When you think about security in your on-premises environment, you need to manage everything. From physical security on the building, to physical security of the IT devices, through to environment controls, operating system, application, data, etc. This results in a lot of administrative overhead, without much benefit to your business. We've previously heard the term undifferentiated heavy lifting, which referred to running the physical components of the data center. When deploying resources on AWS, we learned that AWS took care of this undifferentiated heavy lifting. That is, we manage all the physical stuff for you. This means AWS has some responsibilities when keeping the cloud secure. On the flip side, AWS does not have access to your data. We also don't have access to resources you deploy. So there will be an element of responsibility that falls onto you as the customer. This is where the shared responsibility model kicks in. It details and highlights what AWS responsibilities and what is your responsibility. Let's look at 2 simple examples. Firstly, when using EC2, it is AWS's responsibility to provide physical, secure compute servers that are available to use. When you deploy an EC2 instance, it is your responsibility to apply ongoing operating system patches. It is AWS's responsibility to provide the ability to encrypt your EBS volumes. However, it is your responsibility to actually enable the encryption. We don't mandate how you must perform something. We provide you with the options, levers, and controls. In a separate example, let's look at S3. It's an AWS responsibility to provide a highly available and durable storage solution for you to use. It's also AWS's responsibility to provide a permission structure that restricts public access. It's your responsibility as the customer to determine what data resides in S3, whether it's encrypted or not, and which identities have access to it. In short, AWS is responsible to provide a robust and secure cloud framework, a framework that provides you, the customer, the ability to operate safely and securely. It's your responsibility to make use of those configuration options, those levers and controls, to appropriately decide which data can reside where, and then to make informed decisions on how you deploy your services. Every service falls into the shared responsibility model. Some services require more responsibility from you, the customer, while others require less. There are many services that can help you manage your security, from encryption to key management to web application firewalls and logging and monitoring, to name a few. We'll start with authentication and authorization. Being configured in a service called AWS Identity and Access Management, or IAM. IAM gives you the ability to securely control access to your AWS resources. You can assign granular permission to users, groups, and roles. You can share temporary access across to your AWS account and also federate users in your corporate network or within an internet identity provider. Let's look at some of the key components of IAM. The core components we'll talk about fall into two categories: identity and permissions. This allows you to decouple or separate the configuration of who or what can authenticate into a given system and then what they can do within that system. Users and roles are two forms of identity. A user is a permanent identity. You create it, and the credentials will stay until you choose to remove them. A role is a temporary identity, which can be assumed for a set period of time, at which point will automatically expire. A group is not an entity. Rather, it is a collection of users that make it easier to manage permissions. There are two ways a user can authenticate: via username and password into the management console, or via an access key and secret access key through the CLI or SDK. When you assume a role, you are granted a temporary set of access keys that have a defined expiry. Permissions are granted or restricted via the use of policies. A policy is a JSON formatted document that allows you to grant or deny actions or API calls to resources. These can be attached to users, groups, or roles. Roles are extremely powerful and allow you to create identity federation, where you can create a single sign-on experience for your users or even customers. So in this scenario, IAM could be used to grant employees and applications federated access to AWS Management Console and AWS Service APIs by using your existing identity system, such as Microsoft Active Directory or an LDAP identity store. You can use SAML-based identity management and even single sign-on for a great end-user experience. IAM also provides the ability to use multi-factor authentication as an additional security feature. We previously talked about S3 for object storage. S3 is an example of a service that can have a resource-based policy attached, in this case a bucket policy. Let's look at an example where you have to create a new bucket. The default access configuration blocks all access other than the owner. But maybe you want the ability to grant permissions to everyone, make it public. This is useful if you have content that you want to share publicly. Maybe images on your public website, or a new PDF brochure advertising the latest product you're selling. But what if you want to grant permission to specific users or services, or a set of users, roles, or services? Bucket policies, along with identity policies we have spoken about previously, allow granular control over who or what can access your resources and from where and when. Another way we can ensure the security of our data is to utilize various forms of encryption on objects in our bucket. S3 offers server-side encryption, known as SSE, on objects by either using a customer-provided encryption key a key managed through the Key Management Service, KMS, or have S3 itself manage the encryption key. Using these forms of encryption enables S3 to encrypt your object when data is at rest. S3 also supports HTTPS protocol, which enables encryption in transit. AWS CloudTrail is an example of a service that we can use for security auditing in our AWS account. CloudTrail enables us to track identity activity and API usage in our accounts. We can continuously monitor activities and record API calls against multiple different services in our account. We can use this for compliance, auditing, security analysis, and also for troubleshooting purposes. We can also use this to record in case we need to backtrack and understand how access was granted. So CloudTrail gives us transparency in our account, and we can use that from a security standpoint. Additionally, storing the CloudTrail logs in S3 allows us to reduce the cost of storing that important log data, but also grants us the ability to use various querying tools, such as Amazon Athena, a serverless SQL querying tool. The last service I want to talk about in this session is AWS Trusted Advisor. Trusted Advisor is a tool that sits in the background of your account and provides guidance on how to improve your account across various pillars: security, performance, fault tolerance, and cost optimization, along with identifying any service limits you're approaching or have hit. Trusted Advisor bases its guidance on the well-architected framework, a series of best practices compiled by AWS to help build effective architectures. How does Trusted Advisor work? Let's look at cost optimization. Maybe you have a large EC2 instance, an M5 4x large for example, and it's been operating about 10% utilization for the last month. Trusted Advisor may look at this and say, well, you can reduce the size of this instance and meet the performance objectives, but it'll cost you less, so you can achieve some savings. On a separate note, maybe you have all of your EC2 instances in a single availability zone. If that availability zone were to have an issue, you could potentially lose your entire environment. So Trusted Advisor will give you a warning under the fault tolerance category, suggesting you could deploy your resources across multiple availability zones. There are many checks that Trusted Advisor performs, which are regularly refreshed to give you updates and changes in your account and environment are made. I hope you've enjoyed the session and found it interesting. AWS is a data-driven company, and I'd like to take this opportunity to ask you to complete a survey telling us what you thought of the module. This can help us shape and improve events and learning in the future. You can also reach out to us on the various social sites listed on the slide. Why not test your knowledge? Make sure you complete the knowledge check after the session to see how you're progressing. Thank you for attending this module. It's been a pleasure presenting to you. The final two modules will be presented by my colleague Kritika. Have an awesome day.
Hi, my name is Kritika Kumarpan, and I am a technical trainer here at Amazon Web Services. My job is to teach people about AWS services and help them to learn, upskill, and certify in cloud technologies. We're very glad to have you join us today at Awesome Day Online Conference. In Module 4, we are going to take a look at innovation with AWS. We have 5 key components to discuss in this section. We will talk about IoT, or Internet of Things on AWS, machine learning, blockchain, AWS Ground Station, and AWS Wavelength. With technology as the enabler of innovation, AWS is your trusted advisor, uniquely positioned to help your organization shift to an operating model optimized for innovation. We will start off with Internet of Things. What is the Internet of Things, or IoT? IoT is where a system of integrated devices, such as appliances, watches, features in a car, or even toasters, can be connected to various applications. These connections enable the data to be transferred to and from devices in a bidirectional communication flow over a network. That telemetry data can actually be collected and captured from various embedded sensors, microcontrollers, actuators, processors, and communication hardware that is in the surrounding environment. Automating data collection can reduce the need for human-to-human or human-to-computer interactions. With the number of devices that we have today and billions of IoT devices coming online, there are some inherent challenges with managing large fleets of these things. First of all are the overall updates. We've got devices with firmware, microcontrollers or sensors that we have very lightweight firmware and hardware that we need to be able to keep in sync and updated. Sometimes there are issues with network connectivity. These sensors or devices can be on ships or on various different moving objects where they don't consistently have good internet connections. The second issue could arise is that because these devices are remote, they might not be physically accessible. They may be kind of built into equipments, and we may not be able to readily connect wires to them and be able to update them. And lastly, we might have potentially large fleets of devices in production that we have to manage. How do we manage all the communications to and from the sensors, and maybe between the various different things and sensors? Also, from the analytics standpoint, we might have very low compute power, maybe low spec on device resources. In that case, we may not be able to do calculations or analytics on board on the device. And these devices may also emit very large volumes of streaming data that we need to analyze at a later point. Question is, how do we actually get that data out? How to manage all these devices from the remote standpoint? AWS has IoT services for many of the areas that we just talked about. If you need to potentially take data off from those devices, stream them into a central location, and analyze them, we have solutions like AWS IoT Analytics, IoT Events, and IoT Things Graph. From the standpoint of managing device software, we have FreeRTOS, IoT Device SDK IoT Greengrass, and IoT Device Tester. And then finally, to actually connect and control these various different devices and provide services that allow us to be able to manage the messaging and communication between these different devices, we have IoT Core, IoT Device Management, and IoT Device Defender. Customers in various industries are using AWS IoT in applications for improving industrial processes. An example would be remote patient health monitoring solutions that enable healthcare providers to remotely monitor the status of a connected sensor. Measuring and collecting field crop and ambient data or key capabilities enabled by IoT solutions. IoT is used for connected vehicle and autonomous driving capabilities too. AWS IoT makes it easy for you to build scalable IoT applications that collect, process, analyze, and act on that data generated by connected home devices without having to manage any infrastructure. AWS IoT can use AWS services as building blocks to set up a secure and powerful IoT deployment. With IoT, you can build solutions that help you respond to events in near real time and reduce your concerns about scale, enabling you to focus more on your core business. As you can see here, AWS IoT is connected to multiple different AWS services, some of which we've talked about already today. AWS Lambda to run your business logic, DynamoDB for your database layer. You can build IoT applications that gather, process, analyze, and act on data generated by connected devices. AWS IoT Greengrass is an Internet of Things, open source edge runtime, and cloud service that helps you build, deploy, and manage IoT applications on your devices. It enables your device to act locally on the data that they generate, run predictions based on machine learning models, filter and aggregate device data, thus saving your time, especially in cases where milliseconds matter. In farm fields across the globe, Bayer Crop Science is planting and harvesting seeds to help farmers improve the global food system. Bayer Crop Science uses AWS IoT for collection, processing, and analysis of seed growing data. This solution captures terabytes of data and enables analysts to pull up dashboards from the collection platform. Using AWS IoT, visibility into field conditions are more readily accessible and data can be analyzed much quicker. Let's now talk about machine learning on AWS. First of all, what is machine learning? Using technology to discover trends and patterns, compute mathematical predictive models based on factual past data, build learning models, and make predictions. Starting off with artificial intelligence. It includes really any technique that enables computers to be able to mimic human intelligence. This could be simple or logic if-then statements, can be programmed by hand to, as it mimics, human intelligence. A subset of that is machine learning, which utilizes machines and lots of data to search for patterns in that data, to build logics and models automatically. Essentially, with machine learning, we have a machine that learns based on patterns in that data or come up with its own paradigms and discover its own pattern in that data. Another subset of machine learning is deep learning. This uses a multi-layer approach to perform tasks like speech and image recognition that often require lots and lots of data and many more features. Let's dive a bit into machine learning. Amazon itself is an example of a company that went through a multi-year machine learning journey in order to be a ML-driven company you see today. Amazon had been applying ML in areas such as personalization and supply chain for more than 20 years. ML is an integral part of Amazon. We've improved that original personalization model significantly over time and moved it to other products such as Amazon Prime. We use ML throughout our fulfillment process, including developing a forecast system that can predict the appropriate amount of demand for each product we sell worldwide. In order to deliver on our customer expectation on convenience, cost, and delivery speed, we've developed natural language processing technology to give consumers an entirely new way to interact with technology through Alexa. We've also developed groundbreaking technology with autonomous flight through Prime Air drones and using robotics in our fulfillment centers to get packages to consumers faster. This was a big culture change for us, but it's something every organization can do. Within AWS, we can see the machine learning and AI services, essentially the stack, as having 3 layers. The top layer that we see here, these AI services, they can be used to integrate pretty much immediately in applications where developers have little experience or time for developing models from scratch. The bottom layer of the stack is for expert machine learning practitioners who work with the framework or at the framework level and are comfortable building, training, tuning, and deploying machine learning models. The middle ML service layer provide features and tooling for developers and machine learning experts to use a more managed option. This increases the speed at which they train, tune, and deploy their machine learning models. Let's go ahead and take a closer look at the middle layer of the ML services with Amazon SageMaker. Traditional machine learning ML development is complex, expensive, time-consuming, and error-prone. Amazon SageMaker removes the difficult work from the process and empower you to build, train, and deploy ML models quickly. Before SageMaker, doing ML was just too hard for most customers. By making ML easier at low cost, customers can make better use of their data, which is both valuable and differentiating. Amazon SageMaker makes it easy to deploy your trained model in production with a single click so that you can start generating predictions for real-time or batch data. Let's have a look at a use case here. The National Football League has 180 million fans worldwide. They have engaged with the Amazon Machine Learning Solutions Lab. They had a problem where basically they were generating 3+ terabytes of data and over 1,500 plus hours of playtime per week. They were gathering lots and lots of data, but needed a solution for real-time stats, for reporters and sport announcers to be able to generate those stats during the game while it's being played. The solution they picked up was something called Next Generation Stats. Live data was streamed to AWS from RFID tags on the players themselves and the ball that was being used in the game. Then, those machine learning models were built within Amazon SageMaker so the predictions could be made in real time. That's a good real-life application of being able to generate that data and report on those metrics for all the fans, the newcasters, and sports announcers to get that information as the game is being played in real time. Next, let's take a look at that top layer, the AI services part of the stack. One example here is Amazon Recognition. It makes it easy to quickly add sophisticated deep learning-based visual search and image classification to your applications. With the Recognition API, you can detect objects, scenes, and faces in images, and search and compare faces. If you want to be able to generate metadata or tags for various photos, let's say to do cataloging or searching or management of those. Being able to understand demographics of, let's say, customers, or maybe sentiment of those customers in store as they're browsing and shopping. Maybe face comparison. If we want to be able to determine if the person that just walked through the hotel door, are they a current guest? Have they stayed here before? Things of that nature. It has various other kinds of facial recognition components as well. Recognition allows us to be able to upload photos and extract data from those photos that is relevant for various different applications. As an example of object and scene detection, taking a photo and having it essentially tag and identify different objects from within that photo. Here, you can see we have a man and a woman sitting down at a table looking like maybe they're at a restaurant. It looks like the waiter is holding a pen and a notebook. All the data that we have from that photo, we may want to catalog and then utilize as a way to either search for those photos or potentially use within our machine learning projects. Recognition makes it really easy using detect labels to determine different objects that are within that photo that we provided. With Amazon Recognition, you can easily detect when faces appear in images and videos and get attributes such as gender, age range, eyes open, glasses, facial hair for each. Facial recognition is one of the common forms of biometrics employed across industries for fraud prevention. Do they fit within a certain age range so that we can maybe enrich our dataset and be able to maybe send them specific targeted ads or promotions based on qualities of the individual? Here we are in the AWS console. Let's search for Amazon Recognition Service and choose that from that list. First, we will look at face comparison. This is the reference face, comparing it with a group picture. Result is similarity of 99.9%. Let's look at another example. From my pictures folder on the laptop, I am uploading 2 pictures, one by one to compare. It found a similarity of 99.5% in these 2 faces, but no similarity with other faces. Let's now look at how recognition helps with facial analysis. I'm uploading a picture again from my laptop, straight away got some results. It is 99.9% sure the picture has a face, appears to be a female, and even the age range. Smiling 80% sure, appears to be happy, clicking on more, eyes are open, mouth is closed. So a complete analysis of facial attributes, including the confidence scores. Now let's take a look at the text in the image. It automatically detects and extracts text in your image, as you can see here. Next up, let's look at blockchain. Blockchain technology is well suited for complex workflows that span multiple organizations. Some of you might be familiar with different implementations of blockchain. Possibly one of the most significant or recent implementations of blockchain is Bitcoin or Ethereum, but blockchain can actually be used in a variety of other applications too. And if you're not familiar with blockchain as a concept here, blockchain makes it possible to build applications where multiple parties may need to exchange transactions, and maybe there isn't a central authority in that situation. Here, we're dealing with the notion of decentralized trust. But today, in order to use blockchain in a variety of different applications, it's actually pretty difficult to get started. Building a scalable blockchain network with existing technologies is complex and hard to manage. There are a couple of things that each of the network members in the blockchain or those who participate in the blockchain needs to do. One is manually provisioning hardware. Installing the software, knowing what is the right version of the software that needs to be implemented, and also keeping those things up to date. Creating and managing certificates for access control to the blockchain. And then configuring network components. None of these are insignificant, especially as something as complex as a blockchain cannot be easily implemented.
A blockchain is a distributed ledger that is decentralized, distributed, and immutable, enabling automated process workflows. Let's look at an example that demonstrates how this technology works by visiting the voting process. Traditionally, people go to a trusted location to cast their vote. They mark their ballots, which are submitted through a centralized, trusted party. It's a system that's been developed over a long period of time. But what if, instead of mailing a ballot or visiting a voting booth, you vote using a private digital voting token that's linked to your identification when you register to vote? With a distributed ledger, voter registration, verification, collection, and tallying can be automated. And it's trusted by everyone because identities are protected with digital signatures. The ledger is shared across multiple parties, and any changes made must be agreed upon by all. Participants can see the history of the immutable ledger, replacing the traditional previous need for a trusted third party. This is just one example of how blockchain technology can transform a common process. So how can building a blockchain on AWS be beneficial? You can build a superior blockchain solution by using AWS APIs and service integrations. Just like with a database, you can use the wide range of AWS capabilities to perform various functions on a blockchain. For example, technically savvy voters could incorporate AWS analytics services to gain insights to what is taking place on a blockchain. They could also create live streaming visualizations of how each group is voting across a geographic area. Give your blockchain superpowers, AWS.
Let's look at some use cases for blockchain. Shipping. Blockchain can be used to ensure the entire history of a ship item as it's moving from one country to another and going through that entire shipping system all the way through delivery, and we can ensure the integrity of that system. From raw sourcing all the way through to delivery, we can independently audit and verify the entire journey there to make sure that the item that was shipped where it originated from, the item that we're receiving with a certain degree of confidence. With blockchain, supply chain companies can document production updates to a single shared ledger, which provides complete data visibility and a single source of truth. Another really big use case here is finance and banking, assuring that the transactions are legitimate. Having a way to basically be able to agree among multiple different parties within a network that those transactions are valid and correct. Let's now see some of the qualities of blockchain that enable those use cases. First, this idea of decentralized trust. We talked about financial institutions, or maybe mortgage lenders, basically being able to agree among multiple different lenders or parties that a certain transaction that happened truly happened. They're able to agree to a sequence of steps or the origination of a loan and various components like that. All of the participants in the blockchain network here are able to agree on what had happened. And importantly, they have the transparency to be able to do that. Shifting over to the benefits here. In terms of the transparency around those transactions that happen, every member of that network is able to participate and have visibility to what transactions have happened and the data behind those. Immutability in terms of the transaction can't be altered in any way. Once it has happened, it is permanent in nature. Auditability is one of the other benefits that we get here. Being able to audit that certain controls were followed and certain regulations were followed. Permissionless, the idea that we don't necessarily need to have certain central authorities to be able to give permission within the network here. Everyone is in agreement or not in agreement based on the consensus model. Now, in order to get this decentralized trust and the benefits that we talked about, and in order to realize those, we need to be able to set up the blockchain. It's actually quite complex to be able to set up a blockchain in terms of standing up the right infrastructure, using the right applications and the right code to be able to do that. One solution to this is the AWS Blockchain Services. AWS Managed Blockchain is a fully managed service that makes it easy to create and manage a scalable blockchain network using popular open source frameworks like Hyperledger Fabric and Ethereum. This is something that makes it a lot easier for multiple parties that want to set up blockchain potentially within an industry, or like I said, peers on the network to be able to set up a blockchain to participate in. A couple of significant features. Fully managed. The idea behind fully managed in this case is that you don't necessarily need to wait weeks and weeks for the blockchain to be built out according to the specification. You can create a blockchain network in a matter of minutes. Open source variety. As you have support for two popular frameworks, Hyperledger Fabric and Ethereum. Decentralized. To democratically govern the network. Don't have one member that is more important than another member or can override or change or mutate the state of certain transactions. And lots of other components of this, but also familiar pay-as-you-go cost structure, only paying for the resources that are being used. And integrated, of course, with other AWS services so that you can really take development on that blockchain much further. Let's look at one example of this being used. Nestle is a global food and beverage company with more than 2,000 brands and distributions across 189 countries worldwide. They wanted to uncover transparency around its coffee bean supply beyond just the brokers and suppliers. They really wanted to have an understanding of trades of the raw materials and have more visibility into that. They wanted to track every point in supply chain for this premium coffee. They chose AWS Managed Blockchain to basically trace back every single step in the supply chain from the farmer to the grader to the roaster and then the packer. You think about all the steps that go along in that typical process, from actually growing and sourcing all the way through to when those beans are being packed and then eventually sold. This is an excellent use case where you want to understand the supply chain in the case where the largest amount of coffee bean procured around the world. Nestle and their customers can now track the high-quality single-origin coffee from farmer, logistics, distribution center to customer. Next up, we have AWS Ground Station. Satellites are used for a wide variety of use cases, including weather forecasting, surface imaging, communications, and video broadcast. Sending satellites into space is becoming more and more common and accessible. We're getting more data back from the satellites than ever before. Some real-world use cases and examples of where we can use satellite data are weather forecasting and agriculture. Being able to monitor the crop health and maybe use of water across fields and water levels, commercial food producers can use resources efficiently. Another example is global shipping and anti-piracy. Understanding accurate ship positioning around the world and being able to use satellite imagery and telemetry to do that. Earth observation and fire safety. Maybe helping fire commanders understand what is the lowest heat entry point to fight fires and the most efficient way to do that. Retail forecasting. As simple as it may sound, understanding how many cars are parked in different malls and locations where people shop around the world can help understand how often people are going out to the stores. How much money are they spending within those retail stores? Getting this data back has become much more accessible, but there are still some challenges that remain. Even as it's becoming more common and more accessible to send satellites out to space, the infrastructure required to be able to collect data back is still challenging for governments, universities, and businesses. Today, you must either build your own ground stations and antennas, or obtain long-term leases with ground station providers, often in multiple countries, to provide enough opportunities to contact the satellites as they orbit the globe. The actual ground antennas in this case are difficult to maintain, and it requires a high capital expenditure to actually scale up to collect that data. Even if you can get more satellites out into space and retrieve more data, there are still challenges in terms of the actual infrastructure. That is where AWS Ground Station comes in. AWS Ground Station eliminates these problems by delivering a ground station as a service. This enables you to easily control satellite communication. It is a fully managed service that lets you control satellite communications process that data is coming in. Scaling your operations without having to worry about building or managing your ground station infrastructure. Those actual antennas that you need to lease or to buy to retrieve that data makes it a lot easier with the ground station service. It's a fully managed service, so you don't have to worry about the infrastructure and scaling components underneath that. Requires no maintenance, software updates, or application downtime. AWS does all the heavy lifting for smooth and secure operations. Pay-as-you-go pricing, pretty incredible. Having the ability to just pay for the resources as you need them. And if you no longer need them in the future, you can release them and you don't have to pay for them any longer. There is no licensing requirement here. You can scale your satellite communications as your business needs. Another offering is self-service scheduling, which makes it really easy to schedule time to take the data into your AWS environment. And then from there, to do the analysis and maybe even take advantage of machine learning like we talked about before based on that data. We get near real-time data delivery, so the data can be analyzed very quickly. Let's go to the AWS Management Console. Now search for Ground Station Service and select it. Here is an overview of how it works. You figure out which ground station that you are going to want to interact with. You identify which satellite you're going to interact with. You set the schedule effectively a contact time when you want the satellite to interact with the chosen ground station when that satellite is going to pass by in close proximity to that ground station. Then each of those ground stations have multiple antennas, so you can simultaneously be downlinking and uplinking. The data connection is through a network that's in an Amazon Virtual Private Cloud, and the data gets downloaded directly into it. So now it's in your AWS infrastructure to store durably and then to do whatever analytics and processing you want. Now we will talk about AWS Wavelength. Let's first discuss a couple of drivers for AWS Wavelength. With the advancement of onboard capabilities for many mobile device sensors, like I mentioned before with IoT video cameras, and many other devices are generating large volumes of data, often needing to either compute or process that data very close to the point of data generation. There's a need to essentially have more infrastructure behind the scenes, ready to be able to process that data locally much more quickly. There's another driver here in terms of 5G and mobile edge computing. 5G proliferation for the next 4 years, it's projected that billions of mobile subscribers are going to be on 5G or 5G-ready equipment. We have new use cases like cloud gaming, video streaming, IoT, connected vehicles, and other applications. And then, finally, mobile edge computing. Certain applications, like games, demand requirements like low latency and local processing on those mobile edge computing devices. These drivers are some of the reasons for a need for a product like AWS Wavelength. AWS Wavelength combines the high bandwidth and ultra-low latency of 5G networks with the AWS services we talked about earlier to let developers innovate and build a new class of applications using those again low latency and high bandwidth from 5G. Essentially, we have scalable capacity within the communication service providers, or CSP, within those data centers that are managed and supported by AWS. AWS compute and storage infrastructure is embedded inside the communication service provider mobile network. All the processing and storage can happen much more close to the end user, and again, taking advantage of that low latency for the specific applications. You can then have access to services in the AWS regions. You can use the variety of other AWS services. You can develop applications and deploy them for use with 5G networks globally. A few example use cases for AWS Wavelength. Healthcare is one industry where Wavelength is really making an impact. AI or machine learning solutions for processing the images that are maybe taken from multiple different types of equipment in hospitals, maybe for radiology, and being able to do a real-time diagnosis on very large images or maybe even video that is taken from those machines. Connected vehicles, which we'll see an example of in a moment. Smart factories. Industrial automation applications use ML inference at the edge to detect quality issues on fast-moving assembly lines and trigger actions to remediate the problem. AWS Wavelength enables these applications to be realized without having to use expensive GPU-based servers on the factory floor. The amount of technology enabling vehicular communication system and the degree to which these technologies are interconnected continues to advance at a rapid pace. LG Electronics is using a next-generation CV2X platform on the Verizon 5G network using AWS Wavelength to move data in real time. It uses AWS Wavelength for low latency, high throughput for connected vehicles. You might have autonomous or connected vehicles that need to be able to send large volumes of data, potentially stream it in real time, and process that data very, very quickly with low latency and get either decisions or data points back to those vehicles. Over the 5G network, without having to go all the way back to the regions, are excellent use case for something like AWS Wavelength. This concludes Module 4, Innovation with AWS. We hope you found this session helpful with some of the newer innovation areas like IoT, machine learning, blockchain, Wavelength, and ground station. Thank you again for attending, and we really appreciate your feedback so that we can better understand the topics and services you would like to know more about. So please do take time to fill out our survey and let us know what you think. Thanks again for watching. Stay tuned for our next and final module. Hi, my name is Kritika Kumarpan. I am a technical trainer here at Amazon Web Services. We have completed the modules for the day. Now, let's go ahead and talk about some next steps and ways you can learn more even after this. As next steps, I would invite you to choose your path. You can start building immediately by going to aws.amazon.com and create or log in to your AWS account. We'll talk about some of the ways that you can start building on AWS in a moment. Continue learning. I'll talk about some of the different tools and resources that you have to take the step further after our sessions today. And finally, if you want to demonstrate your knowledge, you can sit for an exam and potentially obtain certification in a number of different domains and areas. We'll talk about that as well. So, start building on AWS. Here are some tips that I'd like to give you for getting started. If you haven't worked with an AWS account thus far, good news, we have something called AWS Free Tier. The idea behind Free Tier is it helps you gain free hands-on experience working with some of the services we talked about today and the various different products and features. In order to create a brand new account and utilize AWS Free Tier, you can go to aws.amazon.com/free. That will detail all the free services with either a 12-month trial period or in some cases actually forever free. So take a look at that site to determine the services that you can get some hands-on experience with that won't cost you anything. What I recommend for those who are creating a brand new AWS account is to look into what are called billing alarms. This is really useful for someone who is just starting out with some of these services we talked about. You can go to the billing console in your new AWS account and actually schedule or set up an alarm that will let you know when you're spending over a certain amount. So beyond the free tier, if you decide that you want to use certain services that do incur some charge, you can monitor your cost over time using that and also get alerts. You could also use tools. We have a multitude of developer tools. You can utilize our command line interface, the SDKs, and a number of other resources there. If you go to aws.amazon.com/developer, you can see more about the tooling to start. And last, if you want real-world examples of architectures from other customers and best practices, you can utilize our quick starts. Go to aws.amazon.com/quickstart to see some real-world examples. If you want to continue your learning after this awesome day, you can learn at your own pace by going to the skillbuilder.aws site to gain more confidence and hands-on experience with AWS. We've got lots of different self-paced courses such as the AWS Cloud Practitioner Essentials course. So this way, you can really take your learnings further. You can learn from AWS experts, attend classes led by qualified AWS instructors, and learn how to design, deploy, and operate highly available, cost-effective, and secure applications on AWS. We also have a number of other courses and digital content where you can learn from AWS experts and instructors like myself in the AWS Technical Essentials course. And then finally, if you want to get more hands-on, we've created what are called ramp-up guides. These give you a variety of different resources across a number of different domains to help you gain more real-life experience working with those different services and also get prepared to certify in different areas. Here is a quick view of what these ramp-up guides look like. These are your guides to learning the AWS cloud. And as you will see on screen, we have a number of different domains that you can dive into, and we have lots of different resources to learn more about maybe developing on AWS, maybe within an area like databases or game tech on AWS. We talked about Internet of Things and machine learning. So if you want to learn more about that, we have ramp-up guides in each of those areas as well. For those who are looking for more information on some of the key services and want to get started, Cloud Practitioner is a really great way to understand a little bit more across the different domains we touched on today. So I highly recommend looking at the Cloud Practitioner Ramp-Up Guide to go ahead and get started. After looking at all those services and potentially sitting in another training after today, if you feel like you're ready to validate your expertise, we have AWS certifications. These are from foundational to associate to professional level, with specialty certifications as well. And a good reason to think about certifying is it's a great way to earn recognition and visibility by demonstrating your expertise. Whether you're currently looking for a new job or if you wish to demonstrate your expertise within your current company, certification is a great way to showcase your knowledge. If you're looking to get certified, we have self-paced labs and a number of certification resources on our website. And I'm happy to share that we have a 50% discount exam voucher for our Cloud Practitioner certification. This is available to anyone who has completed all 5 modules at this awesome day. This credential validates cloud fluency and foundational AWS knowledge. If you have an interest in pursuing a career in cloud computing, this is a great starting point. You can find out more about this offer from the handout available for download. Thank you for attending, and we really appreciate your feedback so that we can better understand the topics and services you would like to know more about. So please do take the time to fill out our survey and let us know what you think. And with that, I just want to say thank you so much for joining us at Awesome Day Online Conference. We look forward to seeing you at our upcoming AWS events. Have an awesome day.